Section 7.6 is titled Adding and Subtracting Polynomials. By the end of this lesson, you want to be able to add and subtract polynomials. So let's first do a little bit of review. Let's write the polynomial in standard form. Remember, when written in proper standard form, the degree of each monomial term in the polynomial decreases from left to right, and we need to combine all like terms. So I see two terms here that have the m cubed, so we're going to combine those. If I have 15 m cubes plus 2 more m cubes, there are 17 m cubes altogether. And then we also have 6m squared left over. We cannot combine those are not like terms. And we do have it in standard form because the degree of the first monomial or term in the polynomial is 3, and the degree here is 2. And again, those degrees need to decrease from left to right. Go ahead and put this one in standard form. Remember, combining like terms and then making sure your degrees decrease from left to right. So we have a 3x squared and we subtract 7x squared. So that's a negative 4x squared. We also have 5 and 12. So when we add those, we get 17. And we do have it in decreasing order of degree. This term has degree of 2. This term has degree of 0. Try this one on your own as well. We have 9b cubed c squared plus 5b cubed c squared minus 13b cubed c squared. Hopefully you're recognizing that these are all like terms. They're all like terms because they have the same variables with the same exponents. So now we just need to combine them. 9 plus 5 minus 13. 9 plus 5 is 14. 14 minus 13 is 1. So we get 1 b cubed c squared, or you can just write b cubed c squared. We don't have to write the leading one. And this is in standard form. It's just one term. It's a monomial. So now let's actually talk about simplifying sums and differences. When you're simplifying a sum of two polynomials, you're really just combining like terms. You're taking everything in the first polynomial that can be added to anything in the back polynomial. And so it's just like terms. So really with addition, the use of parentheses is not necessary. So you can drop the parentheses if you want. And now we're just combining like terms. Remember again, like terms have the same variables with the same exponents. Or constants. Constants are also like terms. So if we have 12m squared and we're adding 8 more m squareds, how many m squareds do we have? We have 20m squared plus 9. 4 plus 5. Notice how this is different though from what we were doing in the previous part of this chapter before our last test. We aren't changing our exponents here. We're just adding like terms. So again, simplify the sum. We have t squared minus 6 plus 3t squared plus 11. When you simplify the sum here, you're just adding like terms. So we can drop the parentheses. And I like to underline or circle my like terms so I can see which pieces need to be combined. I have t squared, and I'm adding 3 more t squared. Be careful, that subtraction sign goes with the 6. So t squared plus 3t squared, I have 4 t squareds, and a negative 6 plus 11 is positive 5. So I have 4t squared plus 5. Try 6 on your own, so pause the video here and combine your like terms. I have a w cubed in 2 spots. I have w squared, and I have my constant 4. So you can see we have 3 different like terms. If I have 9w cubed and 7w cubed, that's 16w cubed. I have 8w squared, but I don't have w squared anywhere else, so I just have to bring the 8w squared along. There's nothing to combine with it. And the same thing with the 4, plus 4. Oops, this should have been a cube. So notice again in our final answer, we don't have anything that can be combined, and we do have it written in decreasing order of the exponents from left to right. This is the final answer on number 6. Again, if you want to pause the video here and try 7 on your own, we're combining like terms, simplifying the sum. We are adding polynomials. So I have a 2p cubed and a 9p cubed. That's 11p cubed. I have 6p squared and 11p squared. That's a 17p squared. And I have 10p and 3p. That's going to be 13p. Hopefully you got that as your final answer, and if not, you can see where you went wrong. But now let's switch gears and look at subtracting polynomials. This is a little different, and the use of the parentheses here is necessary. Because we're subtracting each term in the back polynomial from the front polynomial, you kind of think of this negative as a -1, if you want, and it's being distributed through the parenthesis. Essentially, what this subtraction sign does is it changes the sign of everything in the back. So it becomes a minus 9v cubed. If you subtract a -7, that's adding 7v squared. And you subtract a positive 3v, now we're subtracting 3v. So once you distribute that negative sign through the parentheses, now you can combine your like terms and your signs are all correct. So if we have v cubed and we subtract 9v cubed, that's -8v cubed. If we have 6v squared and we add 7 more v squared, you now have 13v squared. And if you have a -v or -1v, you may think of it like that, and we subtract 3 more, we have -4v. So again, notice how the subtraction sign changes everything in the back. You want to make sure you're writing this step out, because oftentimes you'll remember to subtract 9 but then forget to subtract a -7, so you'll get your signs mixed up. So it's important that you do this step. Let's try another one. We have 30d cubed minus 29d squared minus 3d, and we are subtracting the polynomial 2d cubed plus d squared. So again, that subtraction sign, you can think of it as a -1, but it gets distributed through the back parenthesis. So it becomes a minus 2d cubed and a minus d squared. So now we combine like terms. Notice we have this d term all on its own. So we have 30d cubed and we're subtracting 2 more d cubed. So we have 28d cubed. And -29d squared, subtracting another d squared is a -30d squared. And then we have the minus 3d that we need to bring along in the back. No term to combine with that. Couple more examples. Try this one on your own. So pause the video. Please show the distribution of the negative sign through the back polynomial and then do your subtraction. So we have 4x squared plus 5x plus 1. We subtract 6x squared, subtract x, subtract 8. Remember, it's changing the signs of everything inside. So 4x squared minus 6x squared is -2x squared. 5x minus x is plus 4x. Positive 1 minus 8 is a -7, or subtract 7. Also notice in all of these answers, they're written in proper standard form because the exponents are decreasing from left to right. We have a polynomial with, or a monomial term here with a degree 2, degree 1, degree 0. Last example here to try on your own. distributing that negative through, so we have 10p squared plus 5 minus 7p squared plus 2p minus 3. Remember, a negative times a negative is going to be a positive. So we have 10p squared, we subtract 7p squared, we now have 3p squareds. The next term I need is the p term. Notice I only have 2p here, nothing to combine with it. And then we have our positive 5 minus 3. That's a plus 2. So can you add and subtract polynomials? Take another good look at examples 4 through 11. See that you're able to compute those sums and differences on your own. If not, make sure we ask questions tomorrow in class, and we'll work on worksheet 7-6.